Okay, here we go, folks. We got geometry notes 10-1. Our objective today to find the area of parallelograms and triangles. This is theorem 10-1, area of a rectangle. The area of a rectangle is the product of its base and height. That's B times H. So when we're talking about B and H, it's not pure tame sugar right here. This is B and that's H. This is the area of my rectangle. So I multiply B and H and I got it. For that same reason, we can talk about the area of parallelogram. It's still base times height, B times H. Now keep in mind, this is right here, and I've put this in here. This is a rectangle right there. So really it kind of averages that out, and it's the area of a rectangle, base times height. Remember, the heights have to be perpendicular. The base and heights are perpendicular measurements between them so that we can multiply them and find area. Now, the base of a parallelogram can be any one of its sides. Now, keep in mind, if this is the base, this is a height, and the base and height have a perpendicular relationship. This is a perpendicular relationship we're talking about there. Now, I could change it and talk about this base and the height of any shape. The height of any shape is a perpendicular line extending from a side or a line that contains the side. That's pretty important. It's a line that contains the side that we're going to. So this is the height, but this is the base. And this is a line that contains the side there that goes through. So that could be base times height as well. And we talk about the height as an altitude. So the corresponding height altitude is a segment. There's perpendicular line containing that base. Remember, base and height are perpendicular to each other. So now, finding the area of base here of each parallelogram in 1A. Well, I've got the area of a base times height gives me area of this parallelogram. So we'll go 5 times 9. Okay, so we got 5 times 9. 9's my base. I'll pull this out of the way here. And my height's 5. I multiply those together, I get 45, and I gotta make sure I dress up my number and put units on it. Now here, I have more numbers. Now keep in mind the difficulty level of area increases as I give you more information. You have to cut through the junk and be able to tell, hey, that's not needed. So as we're going through and we're making sure we have finding the area, you have to know whether it's a quintessential piece of information or if it's just fluff that's unnecessary information that's just there to confuse you. So here, remember, for area, we need base times height. Well, the significant pieces of information there are perpendicular to each other. Base and height are perpendicular. So this 9 junk that's just sitting there to confuse and tease you. So now we go in and we talk about the base being 10, the height being 8, and then we get her going and we multiply them together and we have 80 inches squared. Now, because I can start ramping up the difficulty, I can start doing all sorts of cool twisting things with the shape. So when I'm looking at this, although this is a base and its measure is 10, it is not the base we're going to use to find the area of this value. Now, keep in mind, we won't use the 10 to find the area because there isn't an associated base height perpendicular combination measures. So we're totally going to be looking here and talking about that being the base. And by the way, you got to remember that a parallelogram, opposite sides of the same measure. So although 8 is over here, it's also right there. And 8 and 12 are perpendicular. So as we go through, we got base, and we have now 8 coming along, okay, and our height, which is 12, and now we just multiply those together and we get 96 millimeters squared. Now, it's your turn, you do D, see what happens. Remember, base heights are a combination of perpendicular values. Okay, hopefully you got them decided. And we go for our base times height. We got 7.5 as our base and 2 as our height. And we got an area of 15 meters squared. Okay, so we've got our area of each parallelogram, and now we're going to move on to our next section, which is talking about just word problems with these parallelograms. In a parallelogram, a base B and its corresponding height h are in a ratio of 5 to 3. The area is 135 millimeters squared. Find B and H. Now we've done this before. We got to write 5 and 3 in terms of x, so that's 5x to 3x. We also know that the area is base times height, and the area is 135 millimeters squared, and the base is 5 and the height is 3. And as we go through, we go 5x times 3x. That's 15x squared is equal to 135. I divide by 15 and find that 9 is equal to x squared. Well, I got to take the square root of both sides here, and we're going to take something called the principal square root because we're looking at the positive value of x. We're not too concerned with the negative value here. So when I take the square root, I find out that x is 3. Well, I'm going to use that over here and find out that my corresponding base height combinations is 15 to 9. Now it's your turn. Same idea. Go for it. Give it a try. Try to emulate what I did in problem 2. And then turn the video back on after you're done. Okay, so in problem 3, in a parallelogram, base and a corresponding height in a ratio of 5 to 2, and the area is 250 centimeters squared. Well, you got to remember, we have 5 to 2. It's in its lowest form of a ratio. We got to introduce the value that was taken out, so we got to put that x back in, and that's going to be 5x to 2x. Okay, well, we're now going to pop that into our equation, and I worked this out because you were supposed to do this by yourself. And now let's talk about this. I had 250 for my area, 5x for my base, and 2x for my height. Multiplied those together, I get 10x squared. It is important that I show my work here. I can't just have scribbles on my paper. I will mark off on assignments and quizzes and tests if I can't read in the direction you're going. Vertical alignment of your problems is important. Now I've got 250 is equal to 10x squared. I divide by 10, I get 25 is equal to x squared. And I take the square root of both sides. Remember, that's what this looks like. Okay, and I find out that 5 is equal to x. Well, because 5 is equal to x, I put it up here. 5 times 5, 2 times 5, and I get my base and height being 25 and 10. Base is 25 centimeters and height is 10 centimeters. And I should have done something like that over here, and I did. I just forgot to show those as we went through. Okay, so we are going to be able to work with ratios. Gosh, we've been doing that since beginning of chapter 7, and this is chapter 10. I wonder if we keep using this stuff the entire semester. Probably. Okay, let's go on to problem 4 here. And in problem 4, it's a little different problem. What I want you to do, you're going to find the area of a parallelogram. Well, you're going to find the area of a parallelogram with the most obvious sides given. Then you're going to find the height of the one you're looking for h, and it's still going to be the same area. So, well, let's just do this. Let's do one of these. I got 4a going on here, and when I'm looking at 4a, I've got base times height, and I'm going to grab 8 and 3. And people are like, what? Where did you get 8 and 3? I got 8, I got 3. They're perpendicular, and down here is 8 as well. Keep in mind, I am looking for h. The whole job of this thing is to look for h, and I'm going to use h in accordance with 4, because 4 times h is the same as 3 times 8. Okay, so 3 times 8 is 24. The area of base, and I'm going to take this 24 and put it in there. Well, I know that base is going to be 4, and I'm going to pop in h here, and I'm going to divide by 4 and find out that 6 is h. So I found that length of 6 right here, and I used that same area because the area is the same throughout the problem. I want you to try one. Find the area of B, and then use it to help you find h with the side length of 6.5. So I'm telling you right away that the area won't be found initially using 6.5 and h, but you will use that to help you find h. Okay, welcome back. We've got 6 times 7.8. That's going to be our area. And as we multiply those together, we get 46.8 units squared. Okay, so we got 46.8. Well, when we're looking at 46.8, we know that that's the total area of our parallelogram. Well, that's the area that we're going to use. We're going to pop that 46.8 right in here. And we're going to use the idea of 6.5 in for B. So 6.5 is going to go in right here for B, and H is what we're going to find. So as we go through, we got 46.8 equals 6.5 times H, and I'm going to divide to find H. And 7.2 is H, okay? So as we go through this, keep that in mind. All this is I'm finding the area and with the values provided with a base and height that are perpendicular, that are actual numbers. And then I'm going to use one of the other measurements that's an actual number in a variable and solve for that variable. So I'm going to do the same thing in C. I got base times height, 3.8 times 4 is 152 units. Or excuse me, 15.2. Yeah, it's important to pay attention to those decimals, isn't it? I got 15.2 units squared. Now I'm going to find H by using 9.5 because 9.5 times H is still 15.2. So we're going to do that, and we got 15.2, 9.5 divide, I get 1.6, and that's my value of H. Okay, so keep in mind, the area is consistent. I can find it using different base height combinations. They must be perpendicular to each other. Okay, as we're sliding on here, let's go on and look at area of a triangle. You've been working with triangles for years. The area of a triangle is half the product of the base and the corresponding height. A equals 1/2 base times height. Now, the reason why this works so slickly or nicely, keep in mind, if I were to just slide this over right here, that is a parallelogram, and that has an area of base times height. Well, check it out. I flip it down, slide it in, that's the same size of that triangle. So really, base times height gives me the area of 2 triangles. I cut it in half, I get 1. So the base of a triangle can be any of its sides, the corresponding height, altitude of the segment, perpendicular to the line containing the base. Hey, kind of like our parallelogram. Now, you guys have evolved as math kids. You got to remember that the more you know, the more junk I can give you, you can throw out because it's unnecessary, unneeded, not pertinent information. So as we're going through and looking at problems, you got to keep in mind, what do I need for the area of a triangle? Well, I need a 5 and an 8, and that's 13, and I need a height. This other stuff, just there to distract you and keep you from finding the right answer that's supposed to be easy. So we got area is equal to 1/2 base times height. My base is 5 plus 8, which is 13. So I got 1/2 of 5 plus 8 times 6. Remember, 5 plus 8 is the base, 6 is the height. We're going to take half of that because that's our formula. And now I've got 39 feet squared. Now, every time you do this, a base and a height are in a relationship that are perpendicular to each other. So if you are grabbing numbers that aren't perpendicular and multiplying them together, you got to be thinking you can't be doing it for an area of a triangle or a parallelogram. So now when we're doing this, keep in mind area is equal to 1/2 base times height. Identify the base, whether it's 9 or 6, because they are perpendicular. Okay, so now 1/2 base times height is 9 times 6, which is going to give us a 27 yards squared. Now, in C, you're going to find out that the base and height combination are a relationship of perpendicular, but the base is a value, okay, that you can find, and in this case in C is 5.5. Is that 5 meters there? That is unnecessary, unneeded information because the height is the perpendicular distance from the base or a line that contains the base to the vertex. Now keep that in mind. Let's read that again. A height or altitude is the perpendicular distance from the base to the vertex opposite it, or a line that contains the base to the vertex opposite it. So this isn't important. What we need here is a base and a height, and we got them. 5.5 and 10.4 are it. And I just multiply them together, and I got my answer, 28.6 meters squared. Okay, now, I'm hoping you're starting to recognize the evolution of difficulty here. We went from, hey, you just got two numbers, a base and a height, and we multiply those together and we get an area, to we got a bunch of numbers there and you have to decide which numbers are important and which ones aren't, to, hey, let's combine shapes. Oh, wait, we're not there yet. We're gonna do some word problems with triangles. Oops, sorry. The area of a triangle is 36 meters squared and the height is 9 meters. Find the length of the corresponding base. Well, the first thing I gotta do is go, well, area is 1/2 base times height. And the area of a triangle is 36 meters squared and the height's 9. Find the length of the corresponding base. Well, I'm gonna pop in 36 to A, 1/2 base times 9, and I'm gonna solve for B, my base. Divide by 9, multiply by 2, multiply it by 2, divide by 9, or just divide by 4.5. Either one works, it'll all get to 8. 8 is my base, and word problem, word answer, the base would be 8 meters long. Now, as we progress in our difficulty level, we start realizing that we can't mix. We cannot mix units when we're multiplying for area the way we're doing this. So when we come across problems like 7a, you want to make a triangular sail like the one at the right. How many square feet of material do you need? Well, first of all, when I go through this, if I got 12 feet 2 inches, that's the same as 12 feet 12 and 1/6 foot, because 2 inches is 2/12 of a foot, which is 1/6. But keep in mind what I'm doing, I've got to change the same units here. So I got 12 feet 2 inches is 12 and 1/6 foot, okay? But I wouldn't really write it that way. I'd go 6 times 12, which is 72, plus 1, which is 73/6. I can write it out like that. And then this next one, I got 3 feet 4 inches. It's the same as 13 and 1/3 feet. And I can multiply at 39, 40 thirds. That's 40 thirds feet. As I'm going to multiply these, I can get those going as fractions. I can also use them as decimals too. See what I did here on this step. I went crazy there. That's going to come out that way. But remember, the intermediate spot here, let's try to fix this for a second, see if I can bring this. We're going to unlock that because really you guys should know that I can go 73/6 40 thirds divided by 2, of course. And that'll come out to be the same darn thing. Okay, as we get this through, and we're just going to double check to make sure. So we got 73 times 40 on top. That's 2920. Divided by 36. It's going to be 81.111111 right there. Okay, so we got it made. So that way you know what those will look like as we go through. Now, the next one in B, I have a couple of ways to go about this. I got 5 inches, I got 1 foot 1 inch, I got 1 foot for my sides, but keep in mind I'm supposed to find area. That's junk. Okay, so I'm going to look at this thing as I go through and put my pens back in so I can tap on my board. That's the same as 5/12 of a foot. Okay, so that's 5/12 of a foot, and that's 1 foot. So I can go 1/2 times 1 and 5/12 is 5/24 feet squared. Or maybe I should say, or I could look at this as inches, because I could go, well, area is equal to 1/2 base times height, which is 12 times 5, which is 72 oh, excuse me, 60 divided by 2, which is 30 inches squared. But no, I want to show you that 30 inches squared. Okay, and remember, there is 1 foot for 12 inches, and there's another foot for 12 inches for our changing our units back into feet squared if I wanted my area in feet squared. And that's 30 divided by 24, or 144, excuse me. And this is 30 over 144, which just would reduce, if I divide by 6, it would just reduce to 5/24 feet squared. So 30 inches squared is the same as 5/24 feet squared, and I don't know why I wrote 25ths, it's actually 24ths, and we've got that nailed, so that's how they're related. Now, we have a find the area of the irregular figures, and keep in mind the consistency with value coming through here. Okay, so I'm going to talk about this as caveman drawing, cave drawings. I've got a cave drawing. I've got a triangle that's 20 long, 8 high. Okay, so I'm going to find the area of that, and I've got a rectangle that is 24 by 20. Okay, well, pretty straight up. Just pop in my values, and I got 8 times 20 divided by 2 is 80. 20 times 24 is 480. And I add those together, and I get myself 560 feet squared. Okay. Now, keep in mind, cave drawing first. Okay, if you're not sure what's going on, break it down. Okay. Remember, I was there the first day they started cave drawings. Yes, that's how old I am. Okay, but cave drawings, we have triangle and rectangle. Okay, the triangle has dimension. The base is 8 because this is 8. So is that. And this height's 5. Okay, this other stuff, extra unnecessary pieces of information to prevent you from finding the right answer. Hopefully you're not cheated away from the right answer. And we have that 1/2, 8 times 5, and then our rectangle is 8 times 5. So we got half of 40, which is 20, plus 40, which is 60. Okay, so we got a 60 meters squared. Now, when you come across problems like C, you got to be careful. We know a whole bunch of stuff, but we got to break it down, and we got to break it down to basics. Okay, we are going to break this one into rectangles and triangles because that's what we've been working with. Well, this is 5, so is this. That makes this 9. Okay, this is 16. This is 6.5. Well, that makes this 9.5, and I should probably say this 9.5 inside that triangle. So I've got a triangle that has this and this with that rectangle. So I'm looking at 9 times 9.5. This is my 9, this is my 9.5, and this is my 5, and this is my 16 to give me my areas. Pay attention to how we're breaking it down, and we break it down to basics. I've had people do some really interesting things with some of these deals. The simpler, the better. I know we got 42.75 plus 80, which is going to be 122.75 meters squared. And ladies and gentlemen, that's all she wrote for today. Today's assignment, as we go through, is our GO 10.1 worksheet. Okay, make sure you set up the problems, make sure you show your work, make sure you put your answers dressed, because we wouldn't want any naked numbers out there. Make sure they have their correct units, and make sure you're always working with the same units in your problem. I hope things are going well, and you guys have a great day. Talk to you soon.